S is for steepness in the hills we must climb. L is for the lean of the tower sublime. O is for obliqueness, obscure as can be, and P is for pitch, not of baseball, nor in plea. E is for elevation, always changing, we hope. And together, these form the concept of slope. It is angle and bank, declination and fall, camber, grade, and rate of change most of all. Gradient and derivative, integrals and flux. To this, the algebra student asks, what the fuck? You know the word and the path I have spoken. The knowledge you gain from the slope is not token, it's a key in mathematics that cannot be outdone as this complex topic starts as rise over run.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, I'll do a brief review of slope and rate of change. So, let's get started. Slope is a word associated with lines. You should already know this, so I'm going to step up the language here to be incredibly accurate and say it this way. Slope is a word associated with lines, and lines are the graphs of the solution sets to linear equations containing two variables. A linear equation in two variables is just a relation between two variables. Often we use x and y. Adjust one variable and the other variable adjusts as well due to the predefined relation, again called the equation, that we have between the two variables. It's this adjustment of one variable and how that affects the other that gives us slope. Now we can start anywhere on this line. If we increase x by 2 units, then the relationship described by the equation forces y to decrease by 3 units. Rather than continually saying, as we increase x by 2, y will decrease by 3, we could just assign this relationship a name and some agreed upon value. The name will be slope, and the agreed upon value is the ratio between the change in y and the change in x. You've seen this before, and it's been written as m. It's a common letter used for slope, and it's a ratio between the change in y to the change in x. You've also seen it as this other fraction, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's kind of important here to note that x sub 1 comma y sub 1 is one of your points, and x sub 2 comma y sub 2 is another point, both occurring on the line. And remember, the line is just a representation of all the solutions to that linear equation in two variables. Finally, we have this last version, which is this fraction, delta y over delta x. That's just a fancy way of saying change in y over change in x. And if you're going to eventually go into calculus, you will see all of this written as dy over dx. What if we were asked to compute the slope of the line going through these 2 points, but we weren't given a visual? Or in other words, we weren't given a graph. Do we actually need to graph the line? Not really, although a quick sketch will reveal that our slope should be negative because the line is falling from left to right. In this case, we should just go right to the formula for slope. Now, remember, it's best to understand a simple formula like slope rather than to just memorize it. Understanding something means that you can recreate it without needing to specifically pull out the exact form your professor or high school teacher made you memorize. Anyhow, slope is rise over run, or change in output over change in input. So let's take a look at these points. Change in output over change in input is what we're looking for here. The outputs are 1 1/2. The inputs are negative 2/3 and 3/7. I have a habit of choosing the second point and writing that first, but slope works both directions, so you could choose to write the first point first and the second point second. So anyhow, change in output. My output ends at 1/2, so I'll write that, minus, and it begins at 1, so 1/2 minus 1. My inputs end at 3/7, minus, and begins at -2/3. Now, using our prerequisite knowledge for simplifying compound fractions, we get the following. And hopefully you can tell that graphing the line and trying to compute the slope from the graph would have been an absolute nightmare here. Starting at a point on the line, y would have to fall 21 units and x would have to run 46. This is before we get back to the line. So that should be pretty convincing that graphing this, while it's great to see that the slope should have been negative, and therefore it is in this case, just graphing this is not going to help us actually compute the slope here. As was mentioned in the opener, there are a lot of names and phrases for slope. The most popular in textbooks are rise over run and change in y over change in x. Although I actually like to rephrase that last one as change in output over change in input, because we often deal with functions. Anyhow, rate of change is what we call the slope when dealing specifically with an application. Now, I want to be clear on this. You could always use the phrase rate of change instead of slope, but when it comes to applications, you should always use the phrase rate of change. I should be pretty honest here. This is a personal preference on my part, but your instructor would probably be overly impressed if you followed that guideline. Anyhow, let's take a look at a quick example. According to Nielsen Market Watch, traditional TV viewing trends have been steadily declining. The year-to-year Q1 data can be modeled by the linear function seen here. What is the rate of change of this function, and what does it mean in this situation? Diving into this function has the form of a linear equation in slope-intercept form. In this case, y is replaced by the function named v of t, x has been replaced by t, the role of the slope is being played by -2.07, and the intercept is 26.98. And I should say it's the vertical intercept, not just the intercept. Since slope is rate of change, we can say that the rate of change of this function is -2.07. However, this is just a number without meaning if we leave it at that. Instead, let's look at the units of the vertical and horizontal axes. Now, they don't quite say it, but the vertical or rise units are hours of TV watching, and the horizontal or run units are the years. So rise over run should be hours of TV watching per year. Throw the numerical value of the rate of change in front of that, and we get our actual interpretation. During the first quarter of each year, the amount of TV viewing time by 18 to 24-year-olds has been decreasing, that's the negative part, by 2.07 hours per year. Way to go, youth of America! I rescind my exuberant congratulations. Thank you for watching this video on slope and rate of change. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar or if it was confusing to you, then I recommend you click on the provided relevant prerequisite links listed below for further help. However, if you find you're continually doing this, you might want to consider speaking with your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Aims for what they are and work together until you feel at ease. Listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.